for 9 independent and dependent events. So when we talk about independent and dependent events, we are doing 2 or more experiments, and if they affect each other, we call it dependent events. If it doesn't affect each other, if the first experiment doesn't affect the second one, first try doesn't affect the second one, we call it independent. So no effect on the probability. Independent if it's effect dependent. There are one or two things we have to know about this one. If A and B are, sorry about that one, I choose wrong pen. Let's choose highlighters, choose red color, that's better, okay. If A and B are independent events, then A and B together happen, it's probability A multiplied by probability B. If it's independent, we only multiply the probability of them. If A and B are dependent events, so probability of A and B, probability A and probability B, but the difference than A. What the A make difference, we need to calculate that part first. So let's solve some example to make it clear. Okay. Let's see. Determine if the events are dependent or independent. Drawing a red then a blue marble without replacement. Without replacement means you draw a marble, then you didn't put it back. That means you decrease the number of the marble. So what is the question here? Probability of red and then, let's say then, sorry. Then probability of a blue. It doesn't say calculate the probability, but I want to show what does the make a difference. This is dependent. Why dependent? Because when you don't replace the marble, you change the number. So let's draw a back here to make it clear. That's the back. Let's draw, choose a color. How many? 6 red. So 1, 2, 3, 4, 5, 6. And how many blue? 4 blue. 1, 2, 3, 4. A back contains that one. Okay. Now, the first one, drawing a red. What is the probability of red? 1, 2, 3, 4, 5, 6. 6 red. Oh, sorry about that one. Where is it? Here. Okay. 6 red over 10. 10. Now, I draw 1 red. I think I draw 1 red. Now multiplied, I don't replace it, I didn't put it back. Now I need to multiply the probability of blue. What is the probability of blue? Now 4 over in the total it makes 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 over 9. As you see, the first one is affected second one. Why? Before the drawing red, so before red, we draw red. What is the probability of blue? It was equal 4 over 10. But after pulling the red, so after the drawing the red, it's become 4 over 9, not 4 over 10. So because of that, it's dependent, and this is the difference that makes difference in the total. Sometimes it makes difference on both of them. Drawing a heart from a deck of cards and a coin landing on tail. So that's the first start. Let's solve the second start. Probability of a heart and a tail. So when you draw a heart on the cards, a deck of cards, it doesn't change the probability of the coin. So 1 over 4 drawing a heart multiplied by 1 over 2, it's equal 1 over 8. That's how we solve. It didn't affect each other. A card and coin doesn't affect each other. Let's see another example. Let's see another example. An experiment consists of spinning each spinner once. We will spin each of them once. So when you spin the first one, it doesn't affect the second one. So it doesn't change anything on the second one. Therefore, this is independent. Find the probability the first spinner land on yellow. So it will end yellow. What is the probability of yellow? So what is the question first? Let's try the question. Yellow, and the second will be at 8. So in this situation, it's not mutually exclusive. It's not 0. That's it's possible. Yellow and 8 is possible. So it's not mutually exclusive. So it's independent events. Probability of yellow multiplied by probability of 8. What is probability of yellow? There are 2 yellow. 1, 2, 3, 4, 5, 6, 7, 8. 2 over 8. From 8 sector, only 2 of them yellow. Multiply by, again there are 8 sectors, only 1 of them 8. So 1 over 8, that's equal to 2 over 64. If you want to write simple one, 1 over 32, so you can convert it to the decimal. Let's continue. A sack drawer contained 10 white, 6 black and 8 blue. So if 2 sacks are chosen at random, what is the probability of getting a pair of white? So it's asking a pair of white. I choose 2 of them randomly. So when you choose the first one, this is dependent. Why? When you choose the first one blue, so the number of first one white, the number of whites will change and the total will change. So this is asking actually white and white. Probability white and white. That's equal probability white. Then another multiply by probability white. But because be careful here, it's dependent. At the beginning we have 10 white over 10, 16, 24, 10 over 24. Multiply by, now I take 1 white away, now I get 9 white over 23. Number of 9 white and number of total change at the moment. Be carefully because you take away 1 white. So you can simplify by 2, let's make it 5 and 12. And you can simplify by 3, let's make 3 and 4. That's equal 15 over 92. That's 15 over 92. You can convert, you can divide 15 by 92 and you can convert it to the decimal. This is the first example. Let's put it here. This is the first one. The second one, if 3 sacks are chosen at random, what is the probability of getting? Probability of black, then white, then blue. So that will be probability of black multiplied by probability of white multiplied probability of blue. So what is the probability of, let's say L here to show the blue. Okay, what is the probability of black at the beginning? 6 over 24. Multiply, now white, I didn't change the white, so I have 10 white here, over 23, because I took one black away, now total change. Now I took another one, so what's the number of blue? 8 over, now not 23, 22, because now I took 2 of them away. 6 times, when you simplify that one, 3 times it's 24, that's become 2. Let's make that 11, that will be 1. So 10 over 250, sorry, not 253, sorry, that's not 211. So 11 times 23, 253, 10 over 253. You can multiply first then simplify, but that's the easy way to simplification. 6 times 8, 48. So you can simplify 24 and 48. These two gone, only 2 left. 22 and 2 you can simplify by 2. 22 divided by 2, 11. 2 divided by 2, 1. 1 times 10, 10. 23 times 11, 253. Be careful, these are dependent events, because when you take away 1 sacks without replacing or not replacing it, it's dependent. Let's solve last example about this section. A box contains 6 red marbles, 4 blue marbles, 8 yellow marbles. Find the probability of yellow, then red, if a marble is selected and then a second marble is selected without replacing. Without replacing means you are not putting the marble back. So probability of yellow, then red. So that's probability of yellow multiplied by probability of red. Be careful, this is dependent. First, what is it decided? Is dependent or not? This is dependent because you are not replacing it. Okay, what is the probability of yellow? It's 8 over 18. Multiply by, because you are not replacing, the total will change. Probability of red, I didn't change the number of red because I draw a yellow. Now 6 over, and I draw a yellow, didn't replace it, 17 changed to the 18 changed to 17. Let's simplify it. 18 and 6 divided by 6 1, 18 divided by 6 is 3. That's equal 8 times 1 8, 3 times 17, 3 times 7 21, 3 times 1 3 plus 2 5, 8 over 51. That's the probability yellow then red without replacing. Be careful, without replacing, so this makes it dependent. This is the first. Find the probability of yellow then red. It looks like same question. If a marble is selected and replaced, so you are selecting a marble and putting it back. So this is independent because there is no number change. Independent and replaced it back. You are putting it back. That's mean independent. We don't. It doesn't affect the first one. Doesn't affect the second one. So probability of yellow then red. Same idea. Probability of yellow multiplied by probability of red. But here it's independent. So this time 8 over 18 multiplied by, so 6 red, 6 over 18. Let's simplify it. You can simplify by, I replaced it, so 18 didn't change. I draw the yellow, put it back, so the total number didn't change. This is 3. You can simplify that one by 2. 8 divided by 2 4. 18 divided by 2 is 9. 4 times 1 4. 3 times 9 27. So when you replace or without replacing, it's make change. It's changed the question dependent or independent. Be careful about that. That's the end of the chapter 4 section 9. Thanks for listening. I hope it's helped you a bit.